For centuries, ancient sailors whispered tales of hidden graveyards where sea monsters went to die. These mythic beasts, from the kraken to giant serpents, supposedly left their colossal bones in the abyss. But does a true sea monster graveyard actually exist beneath the dark, crushing waves? To find out, we must descend thousands of meters into the deep ocean, where sunlight never reaches. Modern marine biology is finally beginning to uncover the real secrets buried on the seabed. Scientists discovered that the deep ocean floor is mostly a vast desert of silt. Yet, occasionally, oceanographers stumbled upon massive, white formations in the dark. Huge curved arches, resembling the rib cages of long-dead mythical dragons. These discoveries fueled new speculations about the existence of monster graveyards. Could there be specific zones where these massive ocean creatures go to die? To understand this, we must examine the physical laws of the deep sea. Gravity and water pressure govern everything that sinks down from the surface. A dead animal does not remain afloat forever. It eventually loses buoyancy. The cold temperatures of the deep preserve organic matter much longer than at the surface. This preservation creates long-lasting sites of biological decay and recycling. Early ocean explorers lacked the tools to see the full picture of these sites. They could only retrieve fragments of bones using crude bottom trawls. These fragments were often misidentified as belonging to unknown marine monsters. Naturalists of the past wrote elaborate descriptions of these imagined beasts. But the reality of the deep ocean is far more fascinating than any myth. It is a world where death is not an end, but the foundation of life. Let us dive deeper to meet the actual giants that inhabit this dark realm. The true giants of our world are the baleen whales, stretching up to 30 meters. Their massive bodies contain tons of organic energy accumulated over decades. Alongside them are giant squids, deep-sea predators that can exceed 13 meters, and the whale shark, a gentle filter feeder with a skin like a star-filled sky. These creatures live their lives in the vast, sunlit and twilight zones of the ocean. But like all living things, their biological journey must eventually come to an end. When a whale dies, its lungs fill with water, and the body begins to sink. This process is known as the transition of organic matter to the abyss. Under normal conditions, ocean currents can carry the carcass for miles. The cold, high-pressure environment prevents rapid gassy bloating at great depths. This allows the body to sink intact, reaching the bottom of the ocean floor. Upon impact with the seabed, a massive cloud of soft sediment is thrown into the water. The silt slowly settles back down, sealing the carcass into its final resting place. This event marks the beginning of one of nature's most extraordinary events. A single whale carcass provides more organic energy than decades of marine snow. The scent of decaying tissue spreads quickly through the bottom water currents. Creatures of the dark possess incredibly sensitive organs to detect these chemicals. From miles around, organisms begin their slow trek toward the food source. This process is known in marine biology as the colonization of a carcass. It is the first step in creating a temporary oasis on the barren seabed. Soon, the quiet resting place will transform into a chaotic feeding ground. The stage is set for the first phase of the whale fall ecosystem. Within days, the mobile scavenger phase begins with intense activity. Scores of hagfish arrive, boring into the soft flesh like worms. These jawless fish secrete thick slime to deter other competitors. Giant isopods, the deep-sea cousins of woodlice, crawl over the skin. Their tough, armored shells protect them in the crowded feeding area. Up to 60 kilograms of flesh can be consumed every single day. This first stage can last for up to 2 full years. Gradually, the softest tissues are stripped entirely from the bone. Then, the opportunistic phase begins, welcoming smaller colonizers. Crabs and small lobsters cover the exposed white skeletal structure. They feed on the organic-rich sediment surrounding the decaying site. Even the water column above becomes saturated with organic nutrients. Bristle worms crawl in dense mats across the nearby seabed. They consume the organic fats that have soaked into the sediment. The skeleton of the whale becomes a complex, three-dimensional habitat. The shape resembles a sunken, ribbed ship half sunken in mud. To an observer, it evokes the imagery of an underwater graveyard. But this graveyard is teeming with more life than the surrounding ocean. It represents a localized burst of biodiversity in an otherwise empty desert. Every part of the whale is utilized, leaving absolutely nothing to waste. Even as the flesh disappears, the most difficult parts remain. The bones are rich in lipids, which are hard for most animals to digest. Now enters the sulfophilic stage, the most prolonged phase of the whale fall. Specialized organisms arrive to extract nutrients from deep within the bones. These are oxidax worms, also known as bone-eating worms. They have no mouth or gut, relying on symbiotic bacteria to digest lipids. The green roots of the worms penetrate deep into the bone structure. They dissolve the hard bone matrix using acids secreted from their tissue. At the same time, anaerobic bacteria break down lipids within the sediment. This chemical reaction produces hydrogen sulfide, a highly toxic gas. For most animals, this gas is lethal, but here it is the fuel of life. Chemosynthetic bacteria coat the bones in thick, white shag carpet mats. These bacteria convert toxic sulfur into organic sugars, feeding the ecosystem. Snails and limpets graze on these bacterial mats like sheep on grass. This unique food chain operates entirely without any sunlight. It mimics the ecosystems found at hydrothermal vents and cold seeps. A whale fall acts as an evolutionary stepping stone for these species. It allows chemical-loving organisms to disperse across vast, empty oceans. This incredible process can sustain life on a single skeleton for over 50 years. The bone slowly degrades, becoming porous and crumbly. It becomes a mineral sponge, supporting diverse, tiny invertebrate species. The site has transitioned from a fresh carcass to a biogenic reef. A sanctuary, created entirely from the remains of a single ocean giant. But what happens when multiple skeletons gather in the same area? Undersea topography can create geographic focal points for sinking debris. Submarine canyons act as massive funnels, drawing in material from the coast. Ocean currents naturally slow down inside deep depressions and basins. As the current slows, the suspended organic cargo is dropped to the floor. Over centuries, these basins accumulate a high concentration of skeletal remains. This geological phenomenon creates actual, physical skeleton fields. To a human explorer, this scene matches the description of a graveyard. But there are no mythical sea monsters, here only known marine species. These sites are important records of ancient marine life and history. Deep-sea mud layers preserve bones from rapid chemical weathering. Oxygen-depleted zones in certain basins prevent the bones from decaying. This allows skeletons to remain intact for thousands of years. Researchers use robotic submersibles to explore these sensitive zones. The ROV's mechanical arms can delicately retrieve samples for study. Each bone retrieved tells a story of the ocean's biological past. They reveal past migration patterns and changes in whale populations. Modern human activity is now threatening these delicate underwater sites. Commercial bottom trawlers destroyed deep-sea ecosystems in a single sweep. Silt kicked up by trawling Canberry bone reefs under suffocating mud. Protecting these natural gathering points is crucial for marine science. They are unique underwater libraries, preserving millions of years of history. Let us look at the final truth about these mystical sea cemeteries. Science has replaced ancient fear with wonder and deep understanding. The monsters are simply the magnificent giants that we share our planet with. Their physical remains are not wasted. They represent a biological treasure. A single whale fall creates a complex food web that outlives the whale itself. It connects the sunlit surface of the ocean to the deepest, darkest plains. This cycle of nutrients is vital for maintaining the health of our planet. Without these oases, deep-sea life would be much scarcer and isolated. The graveyards are actually centers of intense biological productivity. They show us that in nature, death is never a permanent dead end. It is simply a transformation, a passing of the energy torch to others. Humanity must work to preserve these remote and silent abyssal worlds. International marine protected areas are expanding to cover the deep seabed. This ensures that the deep-sea ecosystems remain undisturbed by humans. The deep ocean remains the last great unexplored frontier on Earth. And every expedition brings back new species and amazing discoveries. The myth of the monster graveyard has been replaced by a beautiful reality. A reality where the bones of the dead sustain the lives of the living. It is a perfect, self-sustaining loop, designed by millions of years of evolution. As long as the giants swim above, the deep ocean will continue to thrive. The mystery of the deep sea is solved, revealing a sanctuary of life.